Geotrig, lesson 18, we're going to talk about advanced word problems. A little forewarning here about word problems. The hardest part about word problems is coming up with the equation. Once we get the equation, you guys know all the math already on how to deal with those equations. But it's getting the right and correct setup. There are two things that you need to know. You can have as many variables as needed. So if there are 15 different things going on, you could have 15 different variables in one equation. The other important part is the number of variables has to match the number of equations. So if you have 17 variables, you will have 17 equations to go with it. Now, sometimes they do that. When you're talking about distance and distances, which is made up of rate, time, and you have multiple people doing different jobs, we can use, instead of distance, you can use number of jobs. So someone's rate times how much time they have can equal the number of jobs. Multiple people working together. Each person has their own rate. Each person can have their own time. But the idea is that they're either going to give you everybody's rate, so automatically they start eliminating some of those variables for you. So it could end up starting with 6 or 7 variables, but then you start putting values in because John works 20 items an hour. Felix works 30 items an hour. And so you start to fill in different pieces that eliminate some of those variables, then you're just down to someone's time. And then you can relate those times. And we're going to start seeing those types of problems coming up as we go through. So you need as many equations as unique variables there are. That's important. So the first problem. The first problem, guys, actually, I wish I would have either had in high school, or if I did, I wish I would have remembered. Because by the time it came down to taking the ACT, taking the praxis to become a teacher, the test there, a standardized test, there were questions like this. And if you're not introduced to something like this, you don't know this wording. Because the wording is what's going to trip us up. We're talking about the number of blues was 4 less than the sum of the whites and the greens. Also, the number of greens equaled the sum of the blues and the whites. How many of each were there if there were twice as many blues as whites? Now that's a lot of information. Here's a cool thing. Each one of those sentences is an equation. Now there's some key words in here. Is means equals, sum, adding, difference, subtract, product, multiply, quotient, division, to be less than, subtract, to be more than, adding. So those are all key phrases and words that you need to know what they are that'll make this easier for yourself. Now, as I said, each one of those sentences happens to be an equation. Now, it's not too bad. The number of blues was, or is, right? So B equals, or wait, is it not B equals? What is the number of blues was 4 less than the sum of whites and greens? This is a classic one that people are going to get wrong. Felix?
B minus 4.
Okay. B minus 4 is what?
Blue was 4 less
Finish it.
W plus G.
W plus G. B for blues, W's for whites, G for greens. This is the classic mistake right here. That's wrong. That's wrong.
It should be, no, it should be B equals W plus G minus 4.
Yes, John says it right. It should be the sum, which is W plus G, and it's going to be 4 less than that. So the minus 4 actually belongs to the other side. There. So B is equal to the sum of the whites and greens, and I'm going to take 4 from that. The way I kind of sit this and separate it is, if I say I have $4 less than you have, there are 2 options. I can take the amount of money I have and add 4 and I'll find yours. Or an easier amount is find out how much money you have and take 4. So to be 4 less than something, you need to know what that something is first, and then I can take 4 from it.
You could add 4 to B, right?
You could be B plus 4. That'll work too. So either you know what the group is, and you subtract what you're 4 less of, you're 4 less than the group. And the group happens to be the sum of the whites and greens. We then move on to the next one. The greens equaled. Now that one's not too bad. That sounds like G equals the sum of the blues and whites. So that's just what? B plus W or W plus P. And then the last sentence, which again, another classic mistake is going to happen here. How many of each were there if there were twice as many blues as whites? So if I was to think about things, we know we are comparing the blues and the whites. But are they the same? Is blue equal white or B equal W? No. So you know something's not the same. To make them equal, I have to do twice as many. So I have to put a 2 somewhere. Does it go in front of the B or does it go in front of the W? It goes in front of the W. Because which one is there more of? Blues or whites? Because it says there's twice as many blues as whites. So if there's more blues, you have to take the number of whites and multiply it by 2 to get more for the blues. Those are the 2 catching points on these things that you're going to make mistakes on if you're going to. We have 3 equations. We have 3 unknowns. So now, basically, I can just substitute. It makes it really easy because substitution. I got B equals. So can't I put that here and there? So it'd be 2W equals whites plus greens minus 4. Is everybody okay with that? And could I also say that the greens equal 2W minus W? Or plus, sorry, that's a plus, isn't it? 2W plus W? Well, I could simplify that greens one. Green is equal to what? 3W. So I'll just put it over here. So I only have 2 equations left. I have 2W equals W plus G minus 4, and G equals 3W. It's a G and a W is left. But G is equal to 3W. Could I substitute that in to G in the equation above it? I'm going to put this there. And if I do that, I'll have an equation with only what? W's. Then I can solve it. So 2W is equal to 2W plus, not 2W, sorry, W. It's a W because I'm putting it into this equation right here. Plus 3W. I'm subbing, so I'll use parentheses because it's inside an equation. Minus 4, yes? And W plus 3W happens to make 4W. I'm going to have to move over here. 2W is equal to 4W minus 4. So we just solve for W. Subtract 4W, which leaves me with what? Negative 2W is equal to negative 4. Divide both sides by negative 2. So W is equal to 2. Think if we're talking about whites, greens, and reds. Generally, you're probably going to have whole numbers and probably positive ones, right? To have something, you can't have a negative of something when it's an object. Wait a minute. If I know the number of whites is equal to 2, can I quickly find another one?
Yeah, B.
Yeah. B is equal to 2 times whites, which is 2, which is 4. Number of blues is 4, the number of whites is 2, and do we have another way? G equals B plus W, or, wait a minute, couldn't I say it right here? G is equal to 3W. So therefore, it would look like G equaling 3, that's an equal sign. Three times 2, which is 6. Number of whites, 2. Number of blues, 4. Number of greens, 6. So next question is, the quarters, nickels, and dimes totaled 20 and their value is $1.90. How many of each kind were there if there are 4 times as many nickels as quarters?
Q plus N,
Okay.
D equals 20.
Q plus N plus D equals 20.
When 4N,
4N.
or
4Q equals N. Now we're not done yet with our, we got the first equation, that's why it equals 20. We still need to work on that $1.90 thing. How much is a quarter worth? And 25 cents is 0.25 plus 0.05 N plus 0.10 D is going to equal $1.90. Right? We got to put our cost, our value equation in there. Now we can go to that 4 times as many nickels as quarters. And again, this is where I start. N equals Q, and I know it's not the same. We have to figure out is, where does that 4 times go? Which one is there more of? There are more nickels than quarters. So if I find the number of quarters, I just have to multiply it by 4. There are your 3 equations. The second equation is correct, but I don't like the way it looks because it has a whole bunch of decimals in it.
put them into fraction.
I could put them into fractions and then fraction bust it, or multiply both sides by the LCD to get rid of it. Not 10 more. 100. I need to move the decimal place 2 places to get rid of all decimals. So therefore, I multiply by 100. Distributing through, I end up getting 25Q plus 5N plus 10D equals 190. Is everybody okay with that? We've done that before. Now, I need to get rid of, I got 3 equations and 3 unknowns. Everybody's okay with that? Everybody sees that? There are 3 equations. The black top one, the red one at the bottom, and the N equals 4Q. What do you think I can do with that N equals 4Q?
Figure out what 4Q is.
No, I can't yet.
Divided by 4.
Can I sub that in? So could I say that I'm going to sub it in for N in both of those cases? So Q plus 4N plus D equals 20. I can also say 25Q plus 5 times 4N plus 10D equals 190. What's Q plus 4? That's 4Q, not 4N. Oh my goodness, guys. Just teaching you guys, if you guys make a mistake in your videos, just keep going. Fix it. Should be 4 Qs, sorry. So what's Q plus 4Q? So it becomes 5Q plus D equals 20. And 5 times 4 is 20Q. So really, there's a 20Q there. I'm just going to put it really small on the bottom of it. But what's 25 plus 20? Hopefully everybody understands that's 45 plus 10d equals 190. We're down to 2 equations and 2 unknowns. You guys should be able to handle that for sure. You've done that the last 3 years. They're both right here. They're both. The 5d plus d equals 20 and 45q plus 10d. I need to get rid of one of those variables. What's the easiest one to get rid of? I can multiply the top equation by one of 2 choices. You could divide the second equation by 5, but that would not, you would have to still do another step to eliminate. Generally, we like to multiply and not divide equations, but it still is an option. Felix?
Multiply the top one by minus 10.
Yes, I would multiply the top one by a negative 10 because that'll eliminate which variable? The d's. 5 times negative 10 is negative 50. Negative 10 times d is a negative 10d. And negative 10 times 20 is negative 200. And when I add those together, the d's will cancel. You're left with negative q equals negative 10. I'm going to run out of room on the bottom, but I am going to force it in there. It's going to be divide both sides by negative 5. So we know that q is equal to 2. Guys, we're talking about money. Can I have a negative coin? Can I have a half of a coin? No. So therefore we know q is equal to 2. Wait a minute. If I know q, put it into there. So n equals 4 times 2, which is 8. Nickels, we have 8 nickels, we have 2 dimes. How do I find how many, or not dimes, 2 quarters, 8 nickels, how many find dimes? Plug it in the first equation. 2 plus 8 plus d equals 20. 10 plus d equals 20, or d is equal to 10. I have 10 dimes, 8 nickels, and 2 quarters. You're done. If you add those values up, you will end up with $1.90. Next problem. We're talking about variation, guys. You've dealt with variation, at least Algebra 1, possibly in Algebra 2. Now, if you remember, we got to talk about direct variation, and I'm going to erase this as soon as we write it. So direct variation, guys, is y equals kx, where k is the constant of proportionality. The whole idea is to give you a value for x, give you a value for y. Can you solve for k? Yes. And that k never changes for this problem. The next one is inverse variation. Inverse variation is y equals k over x. Same idea. The first thing they're going to do is give you the x and y variables as numbers to find the constant, and then you put the constant back into the equation and you solve for the unknown that it wants you to solve for while giving you the rest of the variables. You can have direct by itself, you can have inverse by itself, and like our problem above, it can be an and problem. You can combine both of these together. Okay? So, I'm going to erase this, and as we go through a problem, we will work out here. It says the reds vary directly as blues squared and inversely as greens. When there were 80 reds, there were 4 blues and 2 greens. How many reds were there when there were 8 blues and 10 greens? So, as you can see, the first sentence gives us the equation. The second sentence gives us every variable except for the unknown, or the constant, which is k, so we can solve for it. And then the last equation, since we'll know the constant at this point, it gives us everything but one of those variables. So this is a twofold problem, or threefold. Create the equation, find k to plug into the equation, and then use that k value in the equation to solve for the unknown. So, what is the equation? What does it mean to be reds varied directly? Well, you know then it's going to be R equals, and you're talking about variation, there's a constant. It's directly as blues squared. So therefore, it's going to be R equals KB squared. That's directly. R's, the number of reds, varies directly with the blues squared. But it says and inversely as greens. So to combine them together, the greens are on the bottom. This is our equation. There are 4 variables. The next sentence gives us how many of them? 3. It does not give us k. We got to solve for k. 80 equals k times 4 squared over 2. Plug in the right variable into the right spot. Can you solve for k? I would hope so. What's 4 squared? Isn't that 16? And then it's over 2. So this becomes 80 equals 8k. So that means k has to equal 10. So you know the constant. The constant never changes. So I'm going to rewrite the equation. R equals 10 times b squared over g. That's the equation that we will use. I just subbed in k. The last sentence then says, find r when b is 8 and g is 10. Oh, that's pretty easy. R equals 10 times, what's b? 8 squared all over 10. Hey, here's something really cool. What happens to the 10s? And what's 8 squared? So the reds are 64. That's it. That's all you would have to do. But again, it's the setup of the problems that get us. It's not necessarily the math. Your homework for tonight is page 136, 1, 2, and 3. Have a great day.